Hi everyone and welcome back to Fundamentals of Engineering with Farhad. Mechanics of material, calculation of maximum deflection delta. In this example, we continue our previous problem, which is a prismatic beam with a fixed support at A and a sliding support at B, handling a concentrated load of P at the sliding support at B. We want to calculate delta at B. Last time we calculated the moment created at B. This time we want to calculate the maximum deflection at the sliding support. So that's delta B. Let's approach our problem. To do so, we can again dissect our problem into the two cantilever beams, one handling concentrated load and the other one handling the concentrated moment at free end B, which we already calculate the moment at B in previous video. I will provide the link for that at the end of this video if you want to review that one as well. So delta due to downward force of P is delta B sub P, and the upward delta at B due to moment is delta sub B due to moment. Again, our beam is consists of a two cantilever beam with concentrated load and a moment, and or you can show both of them, concentrated load and moment, that be in one cantilever beam and apply the effect of those uh, loads. So delta B due to concentrated load plus delta B due to concentrated load, concentrated moment, is equal to total deflection. We already calculated delta m sub b, which is PL over 2. Delta B2 due to concentrated load is equal to PL cubed over 3EI. And we need to subtract it from the upward moment. That's MBL squared over 2EI for a cantilever beam with just a moment at the free end. And we already calculate MB is equal to half of PL. Replace that in the main equation, and the only unknown is delta total, and that's PL cubed over 12 EI, which we can easily see in a fixed and a sliding support with a concentrated load of B. Delta B is equal to PL cubed over 12 EI. Thank you.